Hello and welcome to Rail's tutorial. Today's topic would be on solving kinematic problem. In one of our previous lessons, kinematic was explained. The link to the kinematic equation provided up here. Note, the problem we are about to solve were derived from different books. AP Physics 1 Premium, Physics 1 for Dummy, and Physics 2 for Dummy. The link to these books will be provided in the description below. Okay, now let's review some of these questions. Now the first question says, the question concerns the motion of a car on a straight track. The vehicle's velocity as a function of time is plotted below. This is the vehicle's velocity as a function of time. So the first question now says, describe what happens to the car at t is equals to 1 second. So this line here is a t, and the car at t is 1 second. This is 1 second here. What does it indicate? It's here. When t is equals to 1 second, the car's velocity starts to decrease because now the car started from 0 seconds here, but it increases its speed from 0 to, when it got to 1 second, the acceleration began to decrease. You can see here, it started to drop down. So after 1 second, the car's velocity decreased after 1 second, decreased down. Because this first line is for velocity and this is the time. So the velocity began to decrease after 1 second. So here, let's say velocity decreased after 1 second. And it also changed the slope of this graph from positive to negative. It's changed the slope of the graph from positive to negative because instead of it going higher, it went down. Now the next question says, how does the car's average velocity between t is equals to 0 here, that is t is equals to 0, this part, and t is equals to 1 second, this part, compared to its average velocity between t is equals to 1 second to t is equals to 5 seconds. So when t was from 0 to 1 second, you see the velocity was accelerating. But when it got from 1 second to 5 seconds, the velocity was decelerating. So now let's look at it. The average velocity between t is equals to 0 and t is equals to 1 second is what? E, that's the initial velocity, plus half v1 and v2, and the final velocity, which is equals to half the initial velocity at velocity point here was what? 0, plus at final velocity here, when t is equals to 1, was 20. So therefore, when we calculate that, the difference will be 1 over 2 brackets 20, which is 10 meter per second. That's the velocity when t is equals to 0 and t is equals to 1. So now when t is equals to 1 and t is equals to 5, so when t is equals to 1 second and t is equals to 5 seconds, for us to find the velocity to be v bracket initial velocity plus final velocity, which is equals to what? Half initial velocity when v is equals to 1 second is 20. So that's 20 plus final velocity when t is 5 seconds is what here? 0. So therefore, it will be 1 over 220, which will give us 10 meter per second. So in the nutshell, the average velocity of the average of the two velocities are the same thing. So it is the same thing when t is equals to 1 and t is equals to 1 second. The average velocity is the same thing as when t is equals to 1 second and the other t is 5 seconds. All right? Okay, let's look at the next question. What is the displacement of a car from time t is equals to 0 and time t is equals to 7? So now it says, what is the displacement of a car from the t is equals to 0 to t is equals to 7? So for us to find the displacement of this car, and we know this looks like a triangle. This is t is equals to 0 and t here is 7 here. So for us to find the displacement of this car, we'll arrange this in shape. So this first line, we'll call it A. And this other outer triangle here, we'll call this B. So we'll find the first A and add it to the first B. So the first A will be from 0 seconds to 5 seconds. And the second part will be from 5 seconds to 7 seconds. So let's find the first displacement of A. For A, when t is equals to 0 and t is equals to 5 seconds, they will apply triangular law. That's area of a triangle that says half base times height. So half, the base of this triangle is this base here on the x-axis. That is 0 to 5, that is 5 seconds. That shows 5 seconds times the height is the height of this velocity, and here is 20 meter per second times 20 meter per second. By the time we multiply this together, we get 50 meters. That's for A. Then now let's calculate for B. Now if you look at the graph of B, B is on the negative part. It is a down slope. So therefore, it will be an opposite triangle. So instead of saying half base times height, so B will be t equals to 5, t1, 5, and t2 is 7 seconds, right? So therefore, since the B is the opposite negative direction, it will be half, negative half, base times height. And if you see here, the negative half, what's the base? It's from 5 to 7, that is 7 minus 5, that's 2. That's 2 seconds times, what's the height? If you look at the height of 7 here, the velocity is at 10. So we'll line it at 10, negative 10. That is 10. That is negative. It's already covered for this negative line here. But since it's at the other side of the slope, negative. So therefore, by the time we do our calculation, what we have here is negative 10 meters. Now, for us to find the total displacement, the D, will now be equal to A plus B. That would be 50 meters plus minus 10 meters. And that is equals to 50, 10 meter, which is equals to 40 meter. Okay, that is the displacement of, that is what is the displacement, what is the displacement of the car from T0 to T7 is 40 meter. Next question says, plot the acceleration during the interval as a function of time. So for us to plot the acceleration to plot the acceleration, we know that from the segment of the graph that t is equals to 0 to t is equals to 1 second, it has a slope of, that is, it has a slope of dv dt, that is change in velocity over change in time. However, we know that here the velocity, here the change in velocity starts from 0 to 20 meter per second. That is 20 minus 0. Then the change in the time would be what? 1 minus 0. So therefore, this first slope would give us what? 20 meter per second square. That's the first slope. Whereby for the other segment from T1 to T7, so for other segment from T1 here to T7, we have a different slope. So from T1, from T is equals to 1 second to T is equals to 7 seconds, we have a slope too that has A is equals to dV dt, where the V would be the change in velocity. Because if you come up here, the V, the final initial velocity here is what? Excuse me. The initial velocity here is 20, and the final velocity here is negative 10. I will know that the V dt will be the final velocity minus the initial velocity. So we have it as the V minus the T, so it will be initial final velocity 10 meter per second minus initial velocity 20 meter per second. All over the final time 7 seconds, and the initial time is what? 1 second. So let us subtract this. This minus this is what? Minus 30. This minus this is 6. By the time we divide this, we have negative 5. Therefore, the acceleration will be negative 5 meter per second square. So for us to now plot the graph, because we asked to plot the graph. So when we plot the graph this way. Okay, so for us to plot the graph, let's plot this graph now. So we have the graph this way. So this is the velocity and this is the time. And let's say this is 1, 2, 3, 4, 5, 6, and 7. And here is 20 meter per second, 10, and here is 0. And here is negative 10. So in between here will be like negative 5 meter per second, right? So if you want to plot the graph, so the graph will come from 20. It is a line of 20 to 1 second. So that is this plot here. That's where this falls here, 20 to 1 second. So it kind of stops here. Then the other line is from 1 second to 7 seconds at negative 5. From 1 second here, 20 seconds. So that is the velocity time graph that's going to be plotted for that. All right, let's look at the other question. Make a sketch of the object's position during this interval as a function of time, assume the car begins at x is equals to 0. Now for us to plot the graph, we would have, this is the velocity and this is the time. And we know it started from 0 here to 1 second. Then it came down this way and came down this way. So let's call this part A, B, and C. So since section A shows that the object is speeding up in the positive direction, section A shows the object is speeding up in the positive direction, this. And section B shows that the object is slowing down. In section B, you can see the object is slowing down, yet it's still moving in the positive direction at 5 seconds. Then now the object, at 5 seconds, now the object now stops velocity for an instant. Then if you look at section C, this section C, it shows that the object is moving in a negative direction because now it has come towards the negative side. So the object is moving in a negative direction and is speeding up. So the corresponding positive versus time, position versus time graph for this would be, let's draw here. This is position line. This is the time graph. Let's call this P in meters. And this is T in seconds, right? So since starting from from 0, then we say, and this is, let's number this time. This is 1, 2, 3, 4, 5, 6, and 7. So at first line, it moves fast, it speeds up at A, at 1. This is one line 1. It speeds up, but let's call this A. Then it starts slowing down when it got to 5, at 5t. So let's go up this dotted line up here. It starts slowing down here. It's got a 5. Then it's now moving in a negative direction to 7. This is 7. So it moves this to 7. So it goes down that way to 7 seconds. So that is the position time graph for this. All right. A cannonball is shot with an initial speed of 5 meters per second at a launch angle of 40 degrees towards the castle wall of 220 meters. The height of the wall is 30 meters. Assuming that effect due to the air are negligent, use G is equals to meter per second square. So the first one says, show that the cannonball will strike the castle wall. How do we show this now? So for us to show that the cannonball will strike the castle wall, we know that R is equals to, that is range, is equals to V square initial velocity sine 2 theta of the initials over G, which is equals to V square is 50, that is 50 square, that is 50 sine 2, theta is 40, all over gravity 9.8 meter per second square. By the time we calculate this, we'd get the range, that is R, would be 251 meter. So once you have the range now as 251 meter, now we simply need to make sure that the cannon height is less than 30 meter at the point its horizontally displacement is 220 meters. Since the horizontal displacement here is 220 meters, and the height here is 30 meters. What this is the horizontal displacement. If the height of the castle is, this is the height, this is the horizontal displacement. If this height is 30, horizontal displacement is 220 meters. That's what that is saying. So we need to make sure that the cannonball's height is less than 30 meters at the point where its horizontal displacement is 220 meters, so that the ball actually hits the wall rather than flying over it. So to do this, we need to find the time at which x is equals to 20 meters by the first writing. So what that means is we'll look for the x, that is the x is equals to initial velocity times time. Now we know time, we don't know time, so t is going to be, we know initial velocity times time, so t will be x over VO, which is x over VO cos theta. So therefore, t will be equals to this value, x is equals to VO cos theta. That's the t. This one we call this our first equation, equation 1. So thus, in the cannonball's vertical position can be written in terms of horizontal position as followed. Because now, so we're looking, this is the x, we've gotten that part of it. So here, for y of the ball, on the y side, we know that VOT, that is on the y side, minus half GT square is equals to VO sine theta initial x over VO cos theta minus it's got all of this is equals to this. This value is equals to this value, then minus half 2g, minus half g. This t square will be here. So since t is equals to x over VO cos theta, so it will be bracket x VO cos theta. Okay. So now to write that further, so now y would be x, since this first value, x, this VO sine theta over VO cos theta is equals to tan, right? So it will be x tan theta minus g, this is square, gx square over 2v square cos square theta. By the time we substitute this value now, substitute the value for x, for theta, for gravity, for initial velocity, and we'll get, substitute value, then we'll get y at x is equals to 220 meters is equals to 220 meter tan, that is x at tan 40 minus 9.8 bracket 220 square, that is the x over 2 bracket 50 for the velocity. So I'm substituting all these values, all of these values here. That is 50 cos square 40 degree. Okay. So that will give us, by the time we calculate all this thing together, what we'll have will be 23 meters. So that will be the value for y of 23 meters. So therefore, the height is actually less than the height of the castle. So once it hit the ball, it's going to be less than the height of the castle, because the height of the castle is 30 meters per second, but we got 23 meters. Okay. So now this question now says, how long will it take for the cannonball to strike the wall? Say how long? Now we're talking about the time. How long will it take for the ball to strike the wall? Okay, let's see. They will know that time, from the first equation they will know with time is equals to x over initial velocity cos theta. It is from this equation that we had here. And we say time is equals to x v cos theta. And let's substitute the value of x b cos theta. So when we have x is equals to 220 meters, then VO is 50. This is 50 meter per second. And cos is cos 40. By the time we calculate this, t will be equals to 5.7 seconds. So it will take 5.7 seconds for cannonball to strike the wall. Okay. The last question I say, what height above the base of the wall will the cannonball strike? So at what height will the cannonball strike? So it has already been determined here that the cannonball will strike at the height of this 23 meters per second, 23 meters, because that is the height that the cannonball can go. It cannot go higher than the height of the castle. So that's how we have 23. So the height at which the cannonball strike the wall is determined to be 23 meters. That's the answer. Okay. Okay, now this question says, a cannonball is fired with an initial speed of 40 meters per second and is launched at an angle of 30 degrees from the cliff of 25 meters high. First question says, what is the flight time of the cannonball? Now looking for the time spent, the flight time spent to fly. So let's put that together. So now for parabolic trajectory, total flight time can be determined by doubling the amount of times it takes for the parabolic to reach the apex. So however, this what we're talking about is not a trajectory. So that we know that the initial position, the position that is let's call it P1, is 25 meter. That is the highest height. And the final position, let's call it PO, is 0 meters. Okay. Then we also have the initial velocity, VO, so that it's known as VO sine theta, which is 40 sine, and the angle given was 30 degrees. So which gives us, every time we multiply this, that will be 40 and a half, because sine 30 is half. That will give us 20 meters per second. That's our initial velocity. And the acceleration, A, since it's going to go down gravity, that will be negative 10 meters per second square. So the missing variable is the final velocity. So we don't know what the V1 is. We don't know what the final velocity is. So the flight time of the cannonball can be computed using the big five number 3. And the big five number 3 is x y is equals to x o, that is the initial position, plus initial velocity times time, plus half at square. Now let's substitute values into it. So we have this as xy, we don't know that is 0. That is the final position is 0. And the initial position is 25 meter. The velocity here is 20, but we don't know the time. So time is this, right? Plus half. Acceleration is -10. Then this t square, we don't know the time too. Then let's calculate them together. So we have it here as 0 is equals to 25 meter plus 20 meter per second times time plus, by the time we multiply this together, we get us negative. So it will be -5 meter per second square times t square. All right. So let's substitute the value again. 0 is equals to -5 meter per second square times t square plus 20 meter per second times t plus 25 meter. If you see, it's already an equation. So how can we solve this? We can use the quadratic formula. And the quadratic formula that says minus b, it's called the almighty formula that says minus b plus or minus b square minus 4ac over 2a. This is quadratic equation that we're going to apply. So now this b is this 20 meters. So we have it as, since we're looking for time, let's take it down more. So time t will be, since b is 20, so it will be -20 plus or minus the square root of 20 square minus 4, and a is 5. A is -5 minus 5, and b is 25 all over 2a, 2, and a is -5, so -5. Okay, so by the time we multiply this out, so we have t, that is the time, would be -20 plus or minus the square root of 400 minus, time we do this together to be plus 20 times 25, that is 500 all over -10, which will give us t will be equals to -20 plus or minus, this 400 plus 500 is 900 over -10. And that will give us what? -20 plus or minus 30 over -10. By the time we calculate this tomorrow, bring them out in pairs, we say this and this. So t would be, we can say 20 minus 20, like say -20 plus 30 over minus 10, and also that is t, and it can also be minus 20 minus 30 over minus 10. By the time we have this put together, this first t would be this minus this is 10. 10 divided by 10. This first t would be, t can be this minus this is 10 over minus 10, that is minus 1 second. Or t can also be this minus this is minus 50 over minus 10, which is 5 seconds. So t will be -5, 1 second. So t can either be this or 5 seconds. Okay, those are the value of t. So this is the value of t. The time it takes is between 1 second and 5 seconds. So at the time, t can be negative value. The flight time of the cannon can also be 5 seconds. Okay. The next question now says, what is the range of the cannonball? So for us to find the range of the cannonball, let's try and get that down here. The range of the cannonball will be x is equals to initial velocity times time, which would be, we know the initial velocity is what? 40 meter per second cos 30 times the time of 5 seconds, 5 seconds. But when we multiply this together, the range that will give us will be 173 meters. That's the range of the cannonball, 173 meters. So in the graph below, plot the speed of the projectile versus time and the vertical speed of the projectile versus time. So I'm going to look at the horizontal speed versus time and the vertical versus time. From initial launch of the projectile to the instant it strikes the ground. This is the horizontal speed versus time, the vertical speed versus time. So now for us to plot this graph accurately, first let's look at the horizontal speed versus time. Okay, so now we know that the horizontal, that is the initial velocity at y, is equals to 40 meter per second cos 30 degree, and that will give us 34.6 meter per second. So as there is no horizontal acceleration, the horizontal speed of the projectile remains constant throughout the entire flight. So that means the value, the velocity at the horizontal will be 34.6 meter per second over the flight time of 5 seconds. So in that phase, the horizontal speed versus time graph would be, it would be like this. So this is the second, this is 2, 4, 6. And now we're looking at 34.6 meters per second. So here will be 34.6 meters per second, right? So it's around here for the flight time. So this is the graph, how it will be. That's the graph for it. Because here is like 30, here is 20, here is somewhere around 10. This is the initial. So that will be the graph for the horizontal. The initial vertical velocity of the cannonball. So let's look at the vertical, because we look at the horizontal first. And let's look at the vertical. For the vertical speed versus time, and the vertical speed versus time, then we know that the VOY, it's equals to 40 meter per second times sine 30 degree, which is equals to what? 20 meter per second. So in the vertical direction, there is a constant acceleration due to gravity. So we know that the acceleration is a, that is 10 meters per second square. So as the slope of the horizontal of the velocity versus time graph is equals to the acceleration, the resulting velocity versus time graph is a linear line with the negative slope. Since the acceleration due to gravity points downwards. So what that is saying is, let me just plot the graph here. So this is a graph. This is 2 seconds, 4 seconds, 6 seconds. And now we have here 0, 10, 20, 30. And down here is -10, -20, -30. Like I mentioned before, that the resulting velocity versus time graph is a linear line with a negative slope. Since the acceleration due to gravity points downwards, we know acceleration due to gravity points downwards. As the magnitude of the acceleration of gravity is 10 meters per second square, the vertical velocity of the cannonball decreases by 10 meters every second. So at every second, it decreases by 10 meters. With the initial velocity at 20, because now the initial velocity here is 20, this means that after 2 seconds comes down here, and the vertical velocity of the projectile is 0. So after 2 seconds here, it comes down this way, then it just keeps slowing down too. So once it gets to gravity, at every 10 meters per second, every second, it just keeps dropping and dropping and dropping. So after a total of 5 seconds, the vertical velocity of the projectile is -30. After 5 seconds, the vertical will be -30. So here, this is -30. After 5 seconds, it becomes negative. This is 5 seconds here. Becomes -30 here. So after 5 seconds, it becomes negative. After here, it becomes -30. So that is how it's visualized by calculation. So comes down this way. Let's say it becomes -30. So for us to draw the vertical speed time graph properly against this, so it will just be plot the graph out here, this way. So this is 2 seconds, 4, and 6 seconds. Then we have 10, 20, and 30. So if you can remember, it drops down here at 2 seconds. Then, as the meter per second comes down, then it moves up to 5 seconds. That's at 30. This is 5 at 30. Right. So that is how we'll draw it. 5 seconds at 30. Yeah. Okay. So this is going to be the vertical speed versus time. Okay. So that is the graph, or the vertical speed versus time. Right. So this is the end of our problem today. And if you have any questions, just put it in the comment section. If you need more clarifications, just put it in the comment section. Please don't forget to subscribe to the YouTube channel, like, share, and comment. Until the next lesson, bye and have a great day. Thank you.